Hello everyone. So today we are going to talk about very important concept that is neurotransmitter. That how neurotransmitter is synthesized, store and release. And what's going on neuro ending. And what is going on synapse and how drug alter the activities. So you must be knowing that peripheral nervous system is a complex network of neurons that connect brain and spinal cord to the rest part of the body. Then peripheral nervous system consists autonomic nervous system and somatic nervous system. Somatic nervous system control voluntary movement of the body, and autonomic nervous system control involuntary movement of the body. Then autonomic nervous system is further divided into sympathetic nervous system and parasympathetic nervous system. Sympathetic nervous system activated during emergency situation, like at increased heart rate, respiratory rate, blood pressure, blood glucose level, and increased focus or alertness. And parasympathetic nervous system causes relaxation. It decreases heart rate, respiratory rate, blood pressure, blood glucose level, and focus or alertness. So here we discuss sympathetic outflow. That sympathetic outflow come out from spinal cord, but from which part of spinal cord? So we can divide spinal cord into different region like cervical, thoracic, lumbar, and sacral. So sympathetic outflow is a thoracolumbar outflow, mean that sympathetic neuron or neurofiber originated from thoracic and lumbar region. So sympathetic outflow is a diffuses outflow. That means that when stimulus come, it not only activate single neuron or neurofiber, it activate or stimulate all the neuron or neurofiber that present in thoracic and lumbar region. So I will just show one pathway very large, and I am trying to illustrate it diagrammatically for better understanding. So let's suppose this is spinal cord. Spinal cord, and this is preganglionic neuron that release acetylcholine, and this is postganglionic neuron, and this is neuroending, which release norepinephrine, and these are target cell on which norepinephrine act and produce action. So at that point, neurotransmitter is norepinephrine. But how this norepinephrine is synthesized? So this norepinephrine is synthesized in the cell body of neuron and then transported here. Are they synthesized locally? Here. So actually they are synthesized locally here. But how they are synthesized? Let's see the mechanism. Let's suppose someone taken proteinous food. This is GIT tract. And this proteinous food enter into GIT tract and convert into simple amino acid. And these amino acid absorb from GIT tract into general circulation. And then these amino acid from general circulation distribute all over the body and tissue. One of the amino acid that is tyrosine. When tyrosine when tyrosine come into near the nerve ending and to the extracellular fluid, there is a special transport mechanism is present in the nerve ending. Our tyrosine pump mechanism is present in the narrow ending that form the tyrosine end to the narrow ending. Once the tyrosine enter into the narrow ending, enzyme will work on it and convert into DOPA. I think I should draw the structure of tyrosine, molecular structure of tyrosine. This is benzene ring. It contains methyl group, another methyl group, and amine group. This is hydroxyl group, right? So once the tyrosine enter into the terminal lobe, it convert into DOPA by a special enzyme that is tyrosine hydroxylase. Tyrosine hydroxylase enzyme that convert tyrosine into DOPA. So what is added over here? Hydroxyl group is added over here. So now this is DOPA. After that, another enzyme come in action that is convert DOPA into dopamine. That is DOPA decarboxylase enzyme. DOPA decarboxylase, right? So actually, DOPA decarboxylase remove or from carbon dioxide from the basic structure of DOPA and convert DOPA into dopamine. As soon as dopamine produce a directly pump into vesicle. Here vesicle is present. Let's suppose this is vesicle. And here is a dopamine pump mechanism is present. Our vesicular transport system is present and directly pump dopamine into vesicle. Once the dopamine is produced, it immediately pump into vesicle. If dopamine remain in the cytosol, it described by a very dangerous enzyme that is monoamino oxidase that is present within the narrow ending. Let's suppose this is mitochondria. On the surface of mitochondria, there is a special enzyme that is monoamino oxidase, which destroy low molecular weight compound. So, when the dopamine remain in the cytosol, it directly destroyed by monoamino oxidase. So, for the prevention of this mechanism, it directly form into vesicle. When dopamine come into vesicle, inside the vesicle, there is a special enzyme, dopamine beta hydroxylase, that convert dopamine into norepinephrine. Then norepinephrine form complex with some protein and ATP is stored over here. Now norepinephrine is stored here, right? So when stimulus come from central nervous system, it stimulate descending neuronal pathway. When descending neuronal pathway is stimulated, it stimulate sympathetic outflow. When sympathetic outflow is stimulated, eventually these nerve should be stimulated and release norepinephrine.